I'm going to give a little update on my KX LTZ1000A based voltage reference. The box is pretty well complete, ovenized, battery powered box and power supply. I'm not entirely happy with the temperature coefficient that I've been able to measure of the specific board that I put together, so I'm going to build another one. And here's the second KX board. I'm waiting for the LTZ1000A Zener from DigiKey to ship. They're out of stock right now. It should be here ready to ship, I believe, later this month. And also waiting for some more Vishay oil-filled precision resistors. And that's all I need for this unit, this board. And just a quick overview, I have a little linear 20 volt 500 milliamp power supply that I built to power for extended periods of time the reference. I can turn power off, and the reference takes internal battery power. Turn it back on. The circuitry in the box is pretty well foolproof. If the voltage drops below 18 volts, switch to the battery power. If it's above 22 volts, it switches to battery power. Little indicator here in the front tells me that it's running on external power. Same little blue light between the two. That was kind of neat. This switch here turns on the oven. It's cold. I'm doing right now the internal air temperature for the ovens at 27 degrees. When the oven's fully warm up, it's have it set for 35 degrees Celsius. And up here, just doing some measurements, just playing around with it. Right, I don't have the buffer board built yet. I'm waiting for this reference board to be built. I'm going to do some tempco measurements on it before I order the precision Vishay resistor network that I'll order to the exact values to get the buffer gain that I need to achieve exactly 10 volts. So I'm waiting for that. I'm going to take both these units apart real quick, pause the video and take both units apart real quick, be right back. So I'll take a little quick look at the 20 volt 500 milliamp power supply. I tried to make it as clean as an output as I could. Here I'm looking at the output voltage, 20.006 volts, close enough, can't argue with that. And for AC noise, 3 Hertz filter, not really measuring any ripple whatsoever. And currently I'm drawing from it virtually nothing. Here is just the reference, which is about 30 to 40 milliamps. Still not showing any ripple. And I'll turn on the oven, which is about 450 milliamps now. And let's see here. Oh, about 0.3 of a millivolt, 310 microvolts. I can live with that. So I'll turn the unit off. Let's take a quick look. Power switch on the back. So I'm using a fused, switched, and filtered AC input block. Little Hammond 25 volt center tap half amp transformer. Little 7800 series 20 volt regulator. Nice thing about this, it's short circuit protected, overcurrent protected, over temperature protected. Simple little regulator, a simple linear regulated power supply, transformer, full wave bridge rectifier, filter capacitor, regulator, some bypassing on the input and output of the regulator, and then just output. That's all it is. Nice little bud box die-cast aluminum case. Tried to fit in there, make it as compact as possible, plus a nice aluminum case, act as a nice heat sink. and that's the power supply. Next we'll take a look at the inside of the reference. Guard for ground, external voltage input, or external power supply input, and this is a little charge connector I have for the lithium-ion batteries I'll show you in a minute. Okay, so on the top cover, you see the guard input, the external voltage input, and the charge connector for the lithium-ion batteries. I'm using a pair of 5S 5000 milliamp lithium-ion batteries. They're velcroed in, and also the strap, Velcro strap, which is epoxied in, and they're also nicely snug in there, just in case someone takes this thing and drops it. Don't want those things to move. And also I made sure there's no sharp objects. Everything's padded around the batteries, around the sides of the case. This board is a current limiting over voltage, under voltage disconnect board. Got it from eBay, sold by a popular Chinese lithium-ion battery charger manufacturer. So if it sees too much voltage, it disconnects the batteries. If it sees an over or too low of a voltage, it will disconnect the batteries from the internal circuit. If over current, it will disconnect the batteries. So it basically protects the batteries from a lot of stupid mistakes that could happen, which could cause the batteries to go up in flames, which this case would contain, but it would do some nasty damage to the rest of the components inside here, and we don't want that. So anyways, we can just pull this top cover aside. You see the balance connectors, then the pair of power connectors. There's separate power fed to this little board here, which then switches power from either let's set this out of the way a little better. Switches power from either battery or external. And then I have just a little 555 timer and op amp for my low battery light. And the low battery light will flash whenever the voltage reads per cell about 3.6. I think, where did I set it? At 3.7. At 3.7 volts per cell, the LED up here will start flashing. Let me know there's low battery. Over here, this is the 15 volt regulator. I'm also doing a little more input filtering over here, DC power filtering, and then power gets fed over to this board where I have a 15 volt regulator for the LTZ1000 reference inside this oven, and also the 7 to 10 volt buffer board, which I again don't have that built yet, but they'll fit in there. Over here is the op amp and the temperature control circuit for the oven. Let me pull the cover for the oven off. 1 second. Okay, I got the cover loose. By the way, if you're wondering how long it'll run on battery power, 10 amp hour battery, and just the reference alone draws about 22, 23 milliamps, somewhere in there. So many days with just the reference on. With the oven on, at room temperature, 22, 23 degrees Celsius ambient room temperature, the oven draws about, with the oven and reference on, about 120, 130 milliamps, and I've run it continuous for 3 days for 72 hours. Still have plenty of battery left. Well, not plenty of battery left, but the low, I didn't hit 3.7 volts per cell. The low voltage light didn't come on, so I probably had maybe 20% capacity somewhere in there left of the batteries. So 3 days is what I can expect to run on average on battery power with the oven on. And again, I'm just using another bud box, aluminum bud box, which is mounted inside the overall enclosure for the for again shielding, and also creates a nice oven. And inside this styrofoam, I have the LTZ reference. Again, I put a little. This is a open cell foam. This is closed cell foam cap I made top and bottom to keep any air currents off the reference itself. But I'm seeing a little bit more thermal or tempco drift to this board than I think I should have. I don't know if it's this board, or maybe if I got one of the components too hot soldering in there, if the reference itself, or one of the precision resistors. So I'm going to build another one and test it and see whichever one works better. And over here I have for temperature, I'm averaging a pair. Here's a 1% precision 10,000 ohm negative temperature coefficient thermistor, and there's another one which is mounted onto the chassis underneath this foam down here to the chassis itself, that measures the temperature of the aluminum oven enclosure itself. And I found averaging the two, I can get a much closer, a much more stable internal air temp, and which is what I'm concerned with. I don't care what the temperature of the aluminum oven itself is. I want the internal air temperature to be as consistent as possible. And then over here I just have the temp probe for the little temperature gauge in the front. It just gives me a sanity check to let me know what the temperature is. The oven control is actually much more stable than the $9 eBay temperature gauge, but it turns out it's remarkably accurate. For heating, I'm using a pair of 25 ohm resistors in series for 50 ohms, mounted on the outside, one over here and one over here. If I was going to make this again, I would have added more resistors. I found that I'm ending up with some thermal gradient variations between the sides of the oven and the rest of it. So I found the placement of the temp sensor for the oven itself was very critical, where I placed it to get the best thermal stability over a varying range of ambient temperature. I found placing it somewhere near the center bottom of the box gave me a much more consistent internal air temp over a 15 degree to 30 degree C ambient temperature range. Can get into a little bit of an oscillation. I would have, if I was going to do this again, I would have used more resistors. I would have put probably 2 on each of the longer sides, then 1 on each side here, and then 2 on the bottom and 2 on the top, and heated it from all sides to keep the box the entire box as stable as possible and consistent as possible, and it would have made it easier to maintain a more consistent internal air temperature. But I'm able to keep between 15 degrees C and 30 degrees C internal air temperature within plus or minus 0.1 degrees Celsius fairly easily. Actually, I've measured a few times within 0.05 degrees, which is close enough for government work. So there you go. And here, let me give a little shot of the front panel wiring. I tried to make it to where I can pull the 4 front screws, and the front panel then folds down and you have access to everything. So it's for any maintenance or adjustment or repair over time that needs to be done, you just pull the 4 front screws and the panel folds forward and comes forward a little bit, and you can get to everything. To help minimize any temperature gradient and thermal EMF between the output wire. This is, of course, the reference output is going to be fed into this board. I'm going to have a buffer, which then the output is going to come out here, and it's got a little bit of a loop. It's also a bit of a maintenance loop, so I can pull the front panel down and get to it. And then to the front jacks are the Trillium copper Pomona jacks. You know, it's going to be pretty darn good. It's not going to be as good as if you're measuring the right off the 7.131 some odd volts right off the reference itself, because adding more solder connections, adding the buffer, and then the jacks up front, each solder connection and each active component between will add a little bit of instability, but you know what? It's a toy. It's more accurate than I need. It's going to be more stable than I need, and it's just a project. It's not going to be used in a laboratory. It's just a little fun little home project. So anyways, there's an update on how it's coming with the ovenized battery powered LTZ1000A based KX reference. Thanks. And here's the little charger dongle. Just used a DB9, not passing through any more than a couple amps. So this will connect like so, and then you can connect this to power supply, 21 volts. It's 3 amps. I've tested 3 amps. The pins handle 3 amps, no problem. Turn that on, and the batteries are already pretty well charged. And then this little bit here is for connecting to I have a little balance monitor here that I can connect. Let me do that real quick. And show the battery power. I can look at minimum, maximum per cell. It's a little bit imbalanced right now because it's charging. If I turn the charger off, let's see, there we go, off. We're looking at a maximum cell difference between cells 4 and 5. Right now it's very low because it's pretty well balanced. It's only 0.02 of a volt between these two cells right here, but every once in a while I'll balance the cells, and they'll prevent any issues. And this little unit turns itself off once it gets down to about less than, I think, 3 or 4 millivolt differential between any of the cells. And then of course I can just hit this again. I can check what the individual cell voltage is. Let's see here, look at each cell. Gives me a relative indication of complete how charged it is, what the charge rate is, and also the total voltage. So that's just my little solution for charging the batteries. I also have a dedicated lithium-ion charger I can use with internal balancing, but it's easy enough to, since rather than digging out the lithium-ion dedicated charger and balancer, I'll just connect it to my lab supply and charge it at 3 amps, and which will take a few hours, and then connect the cell balancer up to it, make sure it's balanced, and good to go.